In the mid-90s, point-and-click web browsers suddenly made the internet accessible to everyone with access to a computer. Internet usage grew so fast that the servers in the early dot-com companies struggled to keep up with overwhelming demand. Netscaler started up at this time to help the dot-coms scale up their capacity as the internet continued to grow. Instead of having to constantly upgrade to bigger and better servers, Netscaler allowed these companies to expand their capacity by simply adding more servers of any type and directing traffic between them to keep the load balanced. The folks at Netscaler made an important decision to build highly efficient software that used off-the-shelf components instead of building custom hardware. This meant that Netscaler's customers could simply update the firmware on their Netscalers to take advantage of new capabilities. Meanwhile, customers using proprietary hardware had to forklift upgrade due to their dependence on the hardware. The big dot-com companies needed a way to automate manual processes because they simply couldn't keep pace with the rate of growth. Since Netscaler was a software-based appliance, it was relatively easy for these hyperscale web companies to write scripts to automate their Netscalers to help grow and secure their infrastructure. By the time Citrix bought Netscaler in 2005, it was so popular that roughly 3/4 of internet users connected through one. As e-commerce turned the web into a competitive marketplace, the server load balancer evolved new capabilities to allow companies to compete on the online experience. The humble load balancer transformed into an application delivery controller, or ADC for short, making websites faster, more responsive, and more reliable for consumers across an ever-increasing variety of devices. Citrix took advantage of the performance and adaptability of the Netscaler to make it the linchpin of its remote access architecture, supporting tens to hundreds of thousands of concurrent remote used sessions. The Citrix ADC became the Swiss Army knife of network appliances as developers added dozens of new use cases. By 2009, most IT departments were taking advantage of server virtualization for faster and more cost-effective deployment of business applications. Thanks to that early decision to build Netscaler around a software-first architecture, Citrix was able to release a version that ran on the customer's own virtual servers. As public cloud providers transformed server virtualization into infrastructure as a service, Citrix ported the same software across to work just as well in the public cloud as it does in the data center. 20 years after the origins of Netscaler, the fundamentals of application architecture began to shift again. Highly digital organizations need to make changes to improve their online services every day, if not every hour. Their capacity needs vary according to business cycles, and they depend on automation, flexibility, agility, and elasticity to remain competitive. These organizations embrace cloud technologies to meet these needs, either building their applications in public clouds or building their own private clouds using similar technology in the data center. This has created a new level of complexity for many organizations. Their traditional applications reside in legacy environments, while the new applications reside in highly automated cloud environments. In many cases, the new applications share the same corporate data or interact with other traditional applications, creating dependencies between systems. This complex hybrid cloud architecture creates challenges for IT architects. Cloud architectures also rely heavily on automation and load balancing across pools of servers. All cloud platforms therefore include basic load balancing services, which are roughly equivalent to the capabilities that Netscaler offered back in the dot-com boom. What they lack is the 20 years of additional user experience optimization and security functions demanded by the evolving lifecycle requirements of online applications. Fortunately, there's an easy solution for companies coming to terms with hybrid cloud architectures. Citrix ADC comes in all form factors to support the physical data center, private cloud, public cloud, and even containerized microservices environments. Citrix Application Delivery Management gives administrators an all-encompassing view of the health and performance of applications and infrastructure across all these environments. They can control the entire ADC fleet from ADM, defining configuration templates and policies to enable self-service by other teams such as developers who want to be self-sufficient but don't have deep skills in network infrastructure or security policy. This also gives security teams a central point of policy control and oversight to ensure all applications adhere to the corporate standards for encryption and application protection. Citrix ADC integrates cleanly with popular automation frameworks, and also the APIs of public clouds. Administrators can build application deployment patterns once based on Citrix ADC and easily move them between different architectures. This brings all of the benefits of over 20 years of application delivery expertise to ensure the best performance and reliability to both old and new applications in even the most complex hybrid cloud environments. The other big challenge of hybrid cloud is cost. The cost of sustaining infrastructure in the data center and also the variable and often overlooked cost of cloud functions such as load balancing and security. Instead of forcing customers to choose between expensive physical appliances and fixed-size software licenses, Citrix offers low-cost, zero-capacity ADC hardware and a subscription-based capacity pool. Hybrid cloud customers simply allocate the capacity where it is needed, regardless of the location or the form factor. Better still, it actually costs less to use Citrix ADC in cloud environments than to consume the basic native services. Throughout its history, Citrix ADC has led the ADC market in innovation. It was the first ADC to support software-based clustering, the first true multi-tenant ADC, the first virtual ADC, and the first virtual ADC to deliver 100 gigabits per second of throughput. Citrix ADC remains the fastest web application firewall on the planet, the first to add support for TLS 1.3, and the only networking solution that can provide detailed user experience analytics and deep security controls for Citrix app and desktop virtualization. Contact your local Citrix expert about how to design and build the next generation platform to deliver highly secure, highly responsive, highly cost-effective applications from your company's hybrid cloud architecture.